Hey, welcome to another morning coffee with Trevor, your host Trevor Matthews. Monday morning, February 7th. What a great day. And once again, my great friend Victor coming to hang out with me. Today is there's a lot going on for me today. I got a lot of great things in the works, as well as a lot of things that I'm developing. But over the last few weeks, I've been working on developing different trainings for different types of contractors, like HVAC contractors, refrigeration contractors. And one of the things that I was diving in deeper to and learning more about is pipe sizing, understanding how to do the pipe work. Probably I've done thousands of feet of piping. I burned a lot of pipe in my day because I did a lot of construction, and it's been a long time. Yeah, it's been 15 years. But the things that I remember is that, I've looked at the piping schedule, I grabbed the pipe that I needed, and then I went and started burning it in and doing this constantly, adding insulation and stuff. But to get to the fundamentals, like I see this time and time again where there's a lot of technicians in construction where that's what they do. They just do all the piping, which is great. And there's some expert pipers on there. But one thing that you need to do to continue to develop yourself is understand those pipes, why they are their size, what the purpose of sloping them, putting hangers on. And it's really important to know that, because you can have rub throughs very easily. You can have the wrong line sizes, and understanding why certain pipes are going where is very, very important. And you're going to see lots of changes coming with, and you are seeing changes with more A12 refrigerants where you have to add certain components, or with A3 refrigerants like R290. But there's this great book that I've used 15 years ago. This is what I was shown in school. It was a book by a gentleman named Garth Dennison. And this guy was a very smart refrigeration professional, wrote lots of books about refrigeration and articles, and was part of all the associations, I believe. I've never met this gentleman, but I've heard lots and lots about Garth over the years. And there's this one refrigerant piping guide that he's written, his name's on it, and it dives into all the different aspects of refrigerant piping. And I've been going through it over the last couple of weeks because there's so many key things that I believe that technicians should know about piping. A lot of us know that, you need a trap if there's so many feet, depending on where you're at, authority of jurisdiction. Maybe say it's 4 feet, maybe it's 5 feet, maybe it's 6 feet, depending on where you're at, or depending on who's teaching or educating you. And same with slope. Some people it's going to say it's a quarter inch slope per 10 feet. But what you really want to do is follow certain principles, because when engineers design a refrigeration system, they have their own uniqueness. So they'll follow different rules for what has worked with them in the past. There's no like set guideline that says, okay, it has to be a half inch per 10 feet, or it has to be a quarter inch slope back to the compressors per 10 feet. So it's kind of what worked for the designer in the past. And so this is where it's important to find and read lots of different articles, documents. And I think this one is a really good one by Garth Dennison. Like design goals. Common goal is to size the suction and header and liquid lines for about 1 degree Fahrenheit pressure drop at design capacity. And I've seen other places where it'll say 2 degrees Fahrenheit. So it's important to really work with people who are designing the system and really understand what the piping is really doing, and why you're doing all these different design characteristics for that system. Good morning, everyone.
Morning.
So there's in this this manual, and I'm going to actually throw it in the chat. I'll throw it in the chat. There's a link to it there. But the suction line must return oil from the evaporator to the compressor at minimum system capacity. That's the main purpose. You need oil at that compressor. So if you don't have oil returning, there's something going on potentially with the piping system or the oil management system, or I meant the piping design. It could be quite a few other things. It could be the compressor itself is running into issues. But you need to make sure that when the system is designed and you're running into an oil issue, you got to figure out why is the oil that's leaving the compressor not returning? Because you may need to add different components. For example, you might have to add an oil management system, something that'll stop that or reduce the amount of oil circulating through the system. Other things, prevent oil draining from an active to an inactive evaporator when more than one evaporator is used in a single system. I've seen this in the field where systems have been designed and piped, and then all of a sudden one evaporator coil is not cooling. Why is it not cooling? Well, the way it was piped was wrong, and that one evaporator was filling up with oil. So you'd always have higher temperature. It wasn't getting the proper heat transfer. So that's another thing why it's important to size and design those suction lines properly. Another one is minimize line sweating from condensation. This is very important if you ever put lines in the ground, and putting them in the ground, you can't access them. You say I've done this before where they've put them, they built trenches, put them in the trenches, and then you use like PVC, depending on who's putting them in the ground. I've seen them where they just drop them in the cement and pour cement right on them. But if you leave any air gaps inside those PVC pipes or whatever types of pipes you're putting the refrigerant pipes in, all of a sudden you start getting ice growing and building up inside there. If you have insulation, just say on a low temp, and ice starts to build up because there's air inside there, or that insulation is not perfectly done, that ice will start to grow. And what do you think ice is going to do to those copper pipes as it continues to grow? It's going to start to squish them. I've pulled out lines out of grounds that are old trenches where half the suction line was just squished down because there was so much ice growing inside the case, and that's something that's not easy to change or replace. I don't know how often people today continue to put them in the ground. Maybe they do. I haven't really asked that question. Another one, prevent any unnecessary heat gain to the refrigerant. That's a huge one that I know technicians miss, going up, and okay, it has insulation on it, but the insulation is outside. It's been beaten and battered from maybe people walking on it, could be from the sun, the UV, maybe it wasn't very good insulation, and it's cracking and flaking off. So if you have insulation that's cracking and flaking off, that should be replaced, because all that heat, especially if it's outside or if it's going through a hot space, it's going to be getting into that gas, and that gas is going to be bringing that back to the compressor. The return gas keeps it cool, the refrigerant keeps it cool, and now if you increase that temperature, you're going to run into other issues that you don't really think of, because you're going there for a problem. You're not really thinking about, oh, is the insulation good or not? Usually not. I guess something that you need to over experience take a look at. Monday mornings are great. I really enjoy Monday mornings, and I want to thank you guys for hanging out. Has any of you ever seen that book before? The Refrigeration Piping Guide by Garth Dennison? Well, now you have. Just click in the link. Big one for liquid lines. You have to size them for a certain amount of feet per minute or velocity. So oil travels really good with liquid. Liquid can move oil, no problem. That's why you're not really worried about velocity in the liquid line. But some of the problems that you can see is that if you have too much velocity, so if you size that liquid line where you have more than, I'll have to look what Gareth says, more than 300 feet per, 300 feet per minute, you may get something called liquid hammering. If you have a solenoid in that line, right? That solenoid opens up and closes down, and it's just a loud bang, and you'll see the line shake. And maybe other issues happening. What'll happen? It'll start to damage up that solenoid, and you'll hear noise. So it's important to understand this stuff as a technician, or notice that when you're at a job site and all of a sudden you hear something like that, because our greatest tools in the field as technicians is our vision, listening, touching and feeling safely, safely for sure, safely, because you get a lot of hot lines that could be running through there, discharge, hot gas lines, whatever it is. But just listening, some of the best technicians I know, they understand what's going on with the system at a larger overview by just listening, walking around, hearing fans, hearing compressors, and doing that. That's what makes a difference. Just understanding, just having, and that comes with experience. That totally comes with experience. Don't expect overnight just to walk into a rack room or into a commercial refrigeration building and you can just all of a sudden hear what's going on. It takes a lot of time and years. Then you'll start to notice things. Well, that doesn't really sound right, or that does sound right. And so it takes experience to do that. But these are the things you should be thinking about over as you're growing and developing yourself as a technician. I should be listening. What does that sound like? What does that solenoid sound like when it opens and closes? Oh, is it banging on and banging off? Is it turning on, turning off? Why is it short cycling? Just these little things. What's that clicking happening inside the compressor? It sounds like fluttering. What's that really mean? Take your time. And now today it makes it a lot easier because you can record this stuff. So you can take your camera and you can record it and you can show it to one of your coworkers. And you can ask the question, or you can send it into a manufacturer and ask them, do you know what this is? Hopefully they'll respond to you. But it's important to understand these piping as a technician. I really believe, and that's why I tell a lot of technicians, if you have an opportunity to do construction, installation, service, commissioning, it's going to give you a well-rounded experience as a technician in the field. Because when I started out in construction, I've done a lot of the wrong things and not thinking from a service technician's point of view, putting valves in places that didn't make any sense, or setting up things that I didn't think of as a service technician's perspective. And really, until I got into service or had someone tell me that was in service before working with me on the construction, Trevor, what happens when you get a call here and you need to isolate this case? What do you mean? Well, you think you're going to have a 14-foot ladder on your truck or a skyjack to get up there to close that ball valve? Yeah, that makes sense. If you're doing a loop system, you just have a couple of big pipes running through the building, and then you're taking circuits off each one. You need to really think and plan that stuff, because as a technician, when you're as a construction technician, you don't really think about that unless you're shown. And it's important to see both sides, I really believe, because when I got into service, I could start seeing the big difference of, wow, this is a lot more difficult. Who would put a ball valve way back there underneath the case? Well, I did stuff like that. Just didn't know. And then when I got back into construction, I had a totally different outlook on putting components, laying the pipes out, structuring the way I did things in construction differently, because I knew that if I ever had a service call there, how do I make it easier for myself? And really understanding refrigeration piping is really important. there's lots of stories that I've talked about with technicians, and I've even seen a lot of them where there's major piping issues, and people chase their tail for a while trying to figure out what's causing this oil issue or this issue where we got to keep putting oil back into the system. Add more oil, and all of a sudden the oil comes back. These are the things that really need to be thought about. And when you lose oil, like, where's it going? Did more people add oil? Maybe. That's why it's good to have job logs. Like I say this time and time again, like when you're doing a job, you should be writing down and talk to your other coworkers. Write this stuff down if there's other people working at that site. It's only going to help both of you out. Be very detailed in your service tickets. You can't remember what you did 6 months down the road. That's very important to have detailed logs, so it makes it easier for you. That at the end of the day, it's making it easier for you and your coworkers by having job logs. And if you run into these oil issues, you got to start looking at different areas. You got to get up into the rafters if you have to and see if it's sloped properly. Is it piped properly? You got to check you got to match the piping schedule. So if you have a ledge inside the mechanical room, you got to match that to what the piping should be, not to the connections on the headers or not to the connections at the case. It's what should the piping be. And then sometimes you have to go out and check the sizing yourself. And I think that's really important. That's how you learn. I know I've done that on quite a few jobs in the past where it's on the piping schedule, but let's take a look at a guide just like this refrigeration handbook and just verify. There's easier things out there now. There's softwares out there. There's actually doing a training on micropipe. I'm working with a great guy named James Bailey from Omega Solutions. He has this great line sizing or system sizing software where you can design a whole CO2 system or a plant by talking about. It'll show you pressure drops and traps that you need, and it's a great line sizing software. We're doing a training on, I think it's March 1st. I'll have to double check. But once again, like, there's other resources than this guide, this refrigeration handbook, but there's so many cool things in this handbook just to review, and if you don't do it, something you'll learn new, right? Because following the principles of people who have done it before and it worked for them is what you should be doing. Trying to recreate the wheel all the time is not always the right step, right? Taking your time, learning the different aspects of design and refrigeration piping. And then there's, on top of that, just not only in this little book, but you need to figure out in your local jurisdiction, what is your code and your mechanical code or your piping code or all that stuff. You need to follow up. And I don't believe we do enough of that. I see when I talk with engineers and designers, they look at more of what the codes are and what should be followed, compared to when here in Canada, we can see the codes when you're in school. We go through them a little bit, and there's a refrigeration code book here. It's a mechanical code. It's B52. And so it's something that we have to follow upon here. But after school, I don't know if there's any technicians, even myself, to be honest with you, until I started diving deeper, wanting to learn more to better myself, does anybody look them up? It's not mandatory to take any more courses or personal development, professional development, continuing development here. You get your refrigeration ticket and that's it. So it's not really up to you or up to the contractor themselves to really help them grow and get better. This is something I'm trying to do, is help more people understand that investing in yourself is so important. Just like all of you here today, hanging out, learning, talking, having a conversation, shooting chats in the chat box is because you want to learn a little bit. I'm hoping you learn one or two things. And my goal is to share a bit of my knowledge to help you, hopefully, either if you already know this knowledge, share it with someone else and help develop them. I think that's very important. Yeah, so it's important to get into the different refrigeration piping books and dive deeper in there. As a technician, I know you're going to learn a bunch of stuff, things that you may have learned in the past, but just maybe remembering it, or stuff that you never even thought about, because pressure drop's a big thing. And I've hear it time and time again. I've talked to manufacturers who, sell their condensing units or their equipment to contractors, and contractors call them, oh, I got oil issue, I got problems, it's not working. And then come to find out is that they ordered the wrong equipment. you know they ordered equipment that wasn't applicable for their application. It could have been from cost, it could have been from whatever it is that maybe the customer was specific on this stuff. But then they come back a lot of times to the OEM and say, well, it's not working. Well, what's your pressure drop in your suction line? I got a 12 psi pressure drop. That's a lot of pressure drop. Or 15 psi pressure drop. Why do you have so much? Well, that should be okay, shouldn't it? Like right there, that means that they don't understand the piping with the velocity, the mass flow that's supposed to happen inside the system. And this is where education is so important. Do you need to know this knowledge on a daily basis? Probably not, but it's something that you should want to know to become a better refrigeration professional, I believe. Yeah, so a couple of things: protect compressor by preventing excessive oil from being trapped in the system, minimize oil loss from the compressor, prevent liquid refrigerant or oil from entering the compressor while operating or in the off cycle, and maintain a clean and dry system. Like, some great tips in this book, and I highly recommend just taking a look at it. It talks about the spacing between the supports, how to support it properly. Once again, may be different where you are located, but it's something that you can take a look at and give you an idea and a well-rounded overview. Once again, too, you need to follow the OEM guide. So whatever piece of equipment that you have, you want to follow the OEM spec. But I've been going through lots of OEM manuals over the years, and some of them have little bit of differences. Like I said earlier, some may say, okay, a quarter inch per 10 feet. Some will say a half inch per 10 feet, sloping towards the compressor. So it's important to understand that. A lot of good manufacturers will have, okay, this is how you should trap it. This is how you should invert it, trap it. This is where you should have your drops and things like that. But sometimes it doesn't have that. Sometimes it's pretty gray. Even if maybe you don't even get a installation manual for the equipment that you're working on. So it's important to know where to find them. The big manufacturers will have them. A lot of them will have them, but you need to find that stuff. Oh, this is fantastic. Anyone have any piping stories that they'd like to share? Okay, so that's really kind of what I want to talk about today. Just check out that refrigeration piping hand guide that I put in there. There's many different, there's a few versions of it. I just found another one. This one here comes from, I don't even know the website. There's another one from HVAC Advisor. So that one's Andy Scowen. I believe that's his last name. So you can go up to his website and pull it off. I'll throw his website in there too. Copy. Put that in the chat for you. And so going to HVACR Advisors, this guy's super smart too. He has an app in there, and I've talked about it before. You just go into his app section and then just refrigerant line sizing. And then you can just throw in the measurements there. Instead of doing it by hand and by charts, you can just do a single line through here. You can try that out, or check out the training on March 1st about micropipe, or look up micropipe. If you have any questions on that design, a line size design software, you reach out to me and I'll send you the Zoom link for it for training. Anybody have any questions before we jump off here?
Hey Trevor, morning.
Joe, what's shaking, brother?
I'm good, man. I'm good. I think with the line size, and I definitely would like you to send me it. The I think it says is there's a link. Well, not the link in the chat, but for like the training.
Yeah. So if you go,
you
can go to my website, go to my events page. So refrigerationmentor.com/events. So check the events page and you can register right there if you want.
That's where all page.
On the events page. Also have a few other trainings come up that are free as well as some that are paid, but that micropipe training is on the Refrigeration Mentor website.
Okay, well, I'll check it out, man.
Awesome.
Yeah, man. Thanks as always, Trevor, man.
You're welcome.
Keep doing the work.
Well, if no one else has any questions, I'm going to jump off here. And you have a fantastic week. And I'll see a lot of you tomorrow. And let's get a conversation going. Thanks.